Hello class, I'm going to go over section 3.2, measures of variation. This will just be the first part of going over this material, and I'll probably have a second and maybe a third part. We'll see how long the videos are. But we're going to go over in our workbook starting with page 68. And this is called section 3.2. This is called measures of variation. So the first thing I want to mention is what is the idea of variation in statistics, okay? And so what variation does is variation helps us understand how the data is spread. And there's several measures of variation. So one of them would be considered the range. When you calculate the range, that's a form of a measure of variation, as opposed to a measure of central tendency, which was 3.1. Calculating the range is more of a measure of variation. And you're familiar with the range from our past quiz number 1 material range, which they use a symbol, they abbreviate it using R abbreviation, and it's the highest value minus the lowest value. Okay, and so I'm actually not going to do this problem. They want you to find the mean and the range of each group here. And so we in the past when we did 3.1 we did work on mean, where we take the average of things. And so I'm actually not going to do that problem. I want to focus more on these measures of variation. And so we have some definitions though to go over. And notice how when we work with variance and standard deviation, they have an example here of a definition of population variance. Now we won't be doing hardly any calculations with population in this book, in this section. Usually when you work your Connect Math, you're given sample variances and sample standard deviations. But if you do have a data set that is from a population, remember the textbook, the problem has to tell you, it has to let you know that, look, this is coming from a population, and then you would have to use a Greek letter of the alphabet to describe that, okay? But it does say here that the standard deviation is the square root of the variance, okay? And so square root, looks like this, so square root looks like that. And then variance, what variance looks like, you can either use s squared, that comes from our textbook, or you can say the square root of s sub x squared. That's also a symbol for variance, and this one comes from your calculator, TI-84. Okay, so I'll show you that in a little bit as we do problems s sub x, but remember it's quantity squared. So when you're trying to calculate the standard deviation and you do know the variance, they're saying you can take the square root of it. And to activate the square root on your TI-84, you would use the second button and then the x squared, because see, that's where you have that radical there. So you would use the second button and then the x squared button, because right above the x squared button is the little radical. Okay, and let me go and give you, I gave you the symbols for variance, so let me give you some symbols for standard deviation. Some symbols for standard deviation. See how this is s sub squared? Well, for standard deviation it's just s. Okay, and again, your text uses x, s. And another symbol is s sub x. Okay, and this one is the TI-84, makes use of that. Okay, TI-84 makes use of its s sub x. And as far as units go, standard deviation makes use of just units. where uh, where variance makes use of units squared. Makes use of units squared. Yeah, and then when you take the square root of units squared, then you just get back units. Okay, so units, and I need my squared. Units squared underneath this radical. Okay, and we're going to do a problem in a little bit, so I'll show you that in more detail about that. The other thing is to give you a little definition for standard deviation. So standard deviation, it's the distance that each data value is from the mean. So here, standard deviation is the distance each data value is from the mean. Okay, so in statistics, they like to keep track of that. These distances, you have the mean in the center, and they keep track of the data value and the mean and the distances that each data value is from the mean. So that's related to standard deviation. The other thing to talk about is your TI-84, to let you know that the TI-84 provides the standard deviation, but the TI-84 does not provide the variance. Nobody's calculator, TI-84, nobody's calculator will provide the variance. It's just like in 3.1, nobody's calculator provides the mode. You have to do that on your own, and you set up a list, data occurrences, number of occurrences for each data, but no one's calculator actually. You can assign, you can sort ascending and descending the data, and then you make your table of the data and the number of occurrences, and you try and distinguish the mode, but nobody's calculator actually gives you the mode value. Well, it's kind of the same thing here. Nobody's calculator will give you the value for the variance. Okay, so you've got to know a couple of ways to figure it, and we're going to show you that in a little bit. So let me just write that down. So the TI-84 provides the standard deviation, and remember that symbol is, S sub x. That's what your TI-84 uses. But it does not provide the variance, which that would be S sub x squared. Okay. So remember here, when we took the variance and we took the square root of that, then that result gave us, is the equal sign. That result gave us the standard deviation. Okay, but the symbol for variance is the squared, little squared S sub x. Okay, that's a symbol that we use. And so now to talk about finding the variance, since the calculator doesn't give that to you, what you would do is, let me write that here. To find the variance, what you would do is you can either square the standard deviation, That's the quickest, fastest way to do that. So whatever value the calculator gives you for the variance, you would take that long decimal value. You don't want to have round off error. So don't round it off and then square it. No, just take that whole value and square it, and that will give you your variance. And also what we'll have you do and demonstrate also on a test at least one time for the variance would be you can use what they call old school, you can calculate the sample computational model. So there's a formula we're going to show you in our workbooks that's called a sample computational model, and you plug those values in, and that will also calculate the standard deviation for you. So let me write that down. So to find the variance, you would square the standard deviation, or you use the sample computational model. So you either square the standard deviation or you use the sample computational model formula. You know, it's a formula. Okay, then down here as I read the bottom part down here, let's see. So the uses of the variance and standard deviation. So it's to determine the spread of the data. Okay, so remember at the top about variance helps us understand how data is spread out. Okay, it determines the consistency of a variable. So for the theoretical part in your homework, in your online homework, you're going to be there. You'll have some problems where you're going to be calculating the variance and standard deviation, and I think one of the examples uses a battery. For example, you'll be calculating the standard deviation and the variance for a battery, for example, and then let me see if I can find that problem in your ebook. It's in something in your ebook, and which will be also related on your homework. And then when they ask you to calculate that on the theoretical part, they'll ask something about does the result seem consistent? So let me see if I can pull that out. I saw it right here. Here we go. Okay, yeah, so something like this. So like this is using, you know, variance and standard deviation for group data, but see this question, can it be concluded that the lifetime of these brands of batteries, talking about battery, see the units here in hours, can it be concluded that the lifetimes of these brands of batteries are consistent. So some of your questions they'll ask that after you calculate the variance and standard deviation, and what that's related to. Here's a good example of consistency that's in your book. So an example of that would be the variation in diameter among nuts and bolts. So the variation in like diameters among nuts and bolts. Okay, so you think about nuts and bolts, like maybe like on a wagon, you've got a wheel, or on a vehicle, you have a wheel on a vehicle, and they've got these bolts, right? Nuts and bolts. And so you want, for as far as consistency, right? We want small, which is close to zero. So close to zero, small. Like, for example, 0.003 units, for example. It's a very small measurement because otherwise, or else, because otherwise, if you don't have that, if you don't have that type of consistency, that smallness, what's going to happen? Then the bolts are going to come off, everything's going to be loose, right? Things are going to come apart, it's going to be dangerous, be hazardous. So, or else what would happen, parts would not fit properly. And some of them would probably come off, right? Okay, so you want to determine the consistency of a variable by computing these variances and standard deviation. And when they ask something like that question said, can it be concluded that the lifetime of these brands of batteries are consistent? When you look at your results, you want something small, close to zero. And if there's something small, close to zero, then we would say yes. Okay. That would be yes for consistency. So I say that we want small, close to zero, small. Okay. So if you had something like, you know, 2 or 5 or even 3 or 2, right? That's not considered small. You want decimal small, okay? Close to zero. Okay, so then it says also the reason for these computing these would be to determine the numbers of data values that fall within a specified interval in a distribution. Okay, so yeah, we're going to do a Chebyshev problem in this section, and that's what Chebyshev problem that we study. That's kind of what we're doing, determining the number of data values that fall within a specified interval in a distribution. Yeah, so you either fall below the mean or above the mean, for example. Okay, and then it's used in inferential statistics. Okay, now some of the characteristics of variation of variances. Variances and standard deviations. Some of the characteristics is that they're usually positive and never negative. And the other thing to note is that standard deviation could actually, it could equals a 0, and the variance, your results could be 0. But if you were to equal 0, this would occur when all data values are the same. It's the same, like all 5s or all 4s. Okay, so 0. Let's see, results when all data values are the same. Okay. Okay, now for page 69 and 70, I didn't Let's see, I don't think I really highlighted anything on that page. Let me just make sure. Let me see. Yeah, it didn't look like until 71. So to see 69, 70, I didn't really highlight anything or do any problems, work any problems out until it was 71. So let me just double check that. Let me just look and see. So, so here's 69. So yeah, 68. Let's see. Let me see why. And I think I know why. It's because, they talk a lot about populations and see population variance. And we really in our Hawks, I mean, really in our Connect Math, we're not going to be hardly calculating anything with populations. And if even if we were, they have to in the problem tell you like this is coming from a population. So we're really actually not doing much calculation on this test and your homework with population. So we did keep it in the workbook. Maybe we should have left it out, but we went and kept it in the workbook. We didn't take it out. But there really won't be a need. See, we use the Greek letters when you're talking about from a population. We use the Greek letters. See, and so you saw how we had the squared. So this would be for the variance, where this is the standard deviation, but this is for a population. So I could teach you that, stress that, but we're not going to be doing those calculations. And so that's why I'm not gonna do this problem here either. Okay. Let's see. So and then same thing for 70. The reason why I didn't work any of these out is because see they're talking about population variance. Yeah, and we're also actually going to do calculation from samples. So that's why I didn't worry about those. Let's see. Okay, now down here it says variance and standard deviation. See, this is good. Sample theoretical model. So this is what we want to focus on from a sample. Okay. So the sample variance, see, there's your S squared from your textbook. Okay. Now this is the formula, but we're actually going to use the computational model. So we're actually not having to make use of this formula. We're going to use the computational model, which is on the next page. And then there's your sample standard deviation. So remember how we had the square root of S squared on the previous page? Let's see. So remember how I had that here? Remember? So sample standard deviation is this. Okay. And then they actually have the formula for that there. Okay. So that's good. We're just not really we're not doing it by hand. Now, maybe on some of your videos, sometimes your videos in Connect Math, they emphasize doing things by hand sometimes, and we're allowed to use a calculator. So don't have to worry so much about that. Okay, so now let's look at 71. So variance and standard deviation sample computational model. Okay, good. So, and this is the formula that we do need. This one right here. We're going to demonstrate this on our tests. The sample variation is S squared, and this formula here. So you do need that this is for test purposes. For test number 1. You do need that formula, okay? So when we take test number 1, you will have some problems from your test review that you'll have to do because your tests are high stakes. When you take your quizzes, they're 5% of the grade. We just had to be able to do this, be able to do that. You decorated a study guide that you could use before you started, taking the quiz. But now when you take the test, it's high stakes. You will have a set of problems that you will have to complete, and that is in your test number 1 module in your Canvas course. And so you want to print that and start working on that as you complete your homeworks. And that will be required to be uploaded before you start your tests. And so it will be kind of locked. It will be locked as like a prerequisite. So before you get to start your tests, which will require Respondus lockdown browser and webcam recording, so you need a password. So you need the password you'll get from Connect Math. Just like recently we took a quiz number 2. So you typed get it to get into your quiz, right? And then it helps me check that you have all your homework done for the related test or the related quiz, 60% or higher. Okay, well then that helps me check that. But then I only put one problem in that assignment in Connect Math for your test. And that's not your test. Your test is in Canvas. The Canvas quiz is what it's called, but it's your test. And you need a password for that. So that password is in that Connect Math assignment under the instructor note. So yesterday when you took a quiz, I had a little instructor note that you read before you started your problems in the quiz. Well, that's where your password's going to be at for your Respondus test. So the system helps me check that y'all got your homeworks done with 60% or higher, but then your goal to get into that a little assignment in Connect Math is to retrieve your password, your access code to start the test. And then before you actually start the test, you have to have uploaded your completed, make a PDF of it and uploaded your completed test review, and you get rewarded for that. That's a bonus. That is worth 5 points bonus because you actually worked problems that we asked you to work, and you can use that while you're taking your time test, which is, I believe, 110 minutes for your time test when you take those. Okay. Okay. And so one of the problems on your test is you're going to have a problem where you're going to compute the variance and you're going to have to use this formula. And then after you do that, then we're going to have you check using the calculator. And the way you check using the calculator, so this is the formula that you use on the test. And then to check on the calculator, what you do basically is you square the standard deviation. Okay. So I didn't say square root it. There's a difference between square root and then just square. So by square, we mean that, right? Squared, okay, times itself, okay? And then here's the sample standard deviation, and you know that as S, and you saw that as the square root of S squared, so you saw that already. Okay, so we'll do that sample problem here. We'll do an example of that here. So if you look at number 1, find the sample variance for the following data set. So on your test, you'll notice that you'll have like blanks for n, for summation of x, for summation of x squared. Okay, and we're going to get those from the calculator. And so what we're going to do is we're going to enter our data. And let's enter it in L1. Okay, so let's do that. And so let's do that. Enter. So go to stat, go to edit, go here and clear this data. Tab over here, go to the top, hit clear, clear and enter. So you clear data and then type in your data 25, 20, 19, 15, 31. Okay. And then you're going to press stat, and then you're going to tab like we did towards the end of 3.1, tab to calculate one variable stats. And then you're going to tell your calculator where your data is at, and we have our data in L1. And this is from the past problem. Remember, we were doing group frequency distributions. Remember, we had some frequencies and some midpoints. So you need to be careful. We don't actually need that here. So you need to tab here and make sure you clear that or delete that and hit enter, and then calculate. Okay, so what we need to grab for now is, okay, see the n is 5. 1, 2, 3, 4, 5. And then you see this summation of x, that's the sigma Greek letter. Summation of x is 110. And then see this summation of x squared, that's 2,572. And what this means, class, for this 110, what this, let me make that better. Okay, what's happening here is they're taking like 25 plus 20 plus 19 plus all the way down to plus 31, and they're getting this. And with this quantity squared, what they're doing here is they're taking 25 squared plus 20 squared plus dot 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 plus 31 squared, and then they're getting this big total. Okay, so large, much larger value because they're squaring each one. Okay, so then now also the other thing I'm going to jot down from here, which we'll need, I'm going to put it at the top. We need, because when we're going to, when we check our work, we're going to use the computational model to compute the value for the sample variance, but then we're going to check it on the TI-84. Now remember nobody's calculator, right? I wrote that earlier, that nobody's calculator will give you the variance, but you can check it using the calculator as a tool. So you can check on TI-84 by doing what? By squaring the standard deviation. And remember, standard deviation is S of x. So you see this right here, see that? S of x, that's your standard deviation. So over here, I'm going to write that down here, S of x, and this is for number 1. And it's 6.164414003, and this is units. That's units. Variance is units squared. Okay, so this is units. And then if I were to square that, so to check on the TI-84, I would square this value, and then that should give me the same value as I get for this. So I'll check it at the end, but let's do this first, okay? And I won't round. Usually we have like the round off rule is round 1 decimal place beyond how your data is given. Our data is given as counting numbers, data presented as counting numbers. So the idea would be you would want to round ideally like to the tens place, then ideally, okay? Ideally you would want to round to the tens place. Okay, although it looks like on your answers here, it looks like it's got a little check mark here. It looks like they went with 38. So if they went with 38, they probably, should have said like 38.0 could round to the nearest tenths. I guess they didn't do that because it just terminated right at 38, but really ideally they probably should have done that. Okay, so when we're going to compute the sample variance, so here you write on your test, your teacher wants a symbol, okay? So we have this, and then, or you can do this, you have a choice, okay? And then you write down the formula, which is that computational, see up here? Computational sample computational model. So that's this right here. Okay, and then I'm gonna start substituting. So you know n was 5. And see, this is this is this right here, this large value, 2,572. Take away, and see this? That's this right here, quantity squared, all over 5 times 5 minus 1. Okay. Okay, now when I use my calculator, when I multiply on your calculator 5 times 2,572, that gives you 12,860. And this, when you take 110 and you square it, so remember you want to use this little key right here. So when you take, and here you just type this and it'll disappear here. 1, 1, 0, and square, enter. So it gives you 12,100. Okay, and then you're going to divide it by 5 times, and this is 5 minus 1, which is 4. Okay, and then that gives you, on the bottom, that gives you 20. And here, when you subtract this on your calculator, you can do this, subtract this on your calculator, you should get 760. And you know, actually these zeros will cross out, you know, every n0, for every n0 on top, you can cross out an n0 on the bottom. And you see half of 70, half of 76 is 38. And this is units squared. Okay, this is 38. Oh, right here, I should have put units squared, sorry. Units squared for, see, for variance. Okay, now, so that's doing it using the formula. That's old school, and so we're going to have you demonstrate that on the test. But then we want you to check it. Check with TI 84, and this is where you will simply square the standard deviation. So we still have this, and then I have that 6.164414003 units squared. So remember where we got that from? Remember this that we got from the calculator over here, remember? So we take that and you square it, okay? So then this is 6.164414003 and then squared. Enter. And then we get 38, see? And units times units, units times units is units squared. So it's 38 units squared. So you see it does check out. Okay, so you will have you demonstrate that on your test. Now, when you do your homework, and Connect Math, and it give you these data values, and I want you to find the variance, then the quick way is just to take, do your calculator commands. So remember the calculator commands was, and again, this is using, let me write this down, this is using the sample computational model. Okay. And remember what we did on the calculator, to get this S of X, to get the standard deviation. Remember you entered your data in L1, remember? And then basically we went to stat, and then we tabbed to calculate, and we went to one variable stats, and then under lists we put list as L1. And remember, we had to leave the frequency list vacant. You want to leave that vacant. And earlier, you might have had something here like L2 from the previous problems we were doing, group frequency distributions. When we were finding the mean, you probably had a frequency list, something L2 there, but this is just L1 data here, no frequency. So leave that vacant, and then you just tab to calculate, and then see that's where your standard deviation is. And then we need to get this value and this value from here, right? And then we had 5 data values. Okay, so leave this vacant, and then it was calculate, and then it was enter. Okay. Okay, good. Okay, and then the last thing I'm going to comment on down here, I'm not going to do this problem, but the last thing I want to comment on is theoretical part. So in your homeworks, oftentimes they will have you compute like the standard deviations and the variances for problems. And then they'll have you compare the data sets, which one's more variable. So like here's an example here, and this is from your ebook, and you're going to have one like this, I believe, on your homework. See, this is your units, square miles. See, miles squared or square miles. So look there how they're asking you to find the standard deviation. So basically, you can type all this data in, and then you press the stat one variable, calculate, and then you're going to see your S of X. You're going to see your S of X value. And then you're going to do that again separately for this. So you have data for these 6 states up here, and then data for these western states. So they're separated, eastern and western. So you're going to do that twice. And you have 2 data sets. So see, find the standard deviation for each data set. It didn't say to combine them. It said each one. But then it says which set is more variable. Which one's more variable? So you need to know this idea. This is important. And that's like a theoretical part. So let me say this, that when the means are approximately equal among 2 or more data sets, then what that means is small standard deviations and small variances. What does that imply? That implies, those imply the data values are near the mean, that they're less variable because they're hovering, hanging around the mean, right? Hanging around the mean, they're less variable. Okay, but or and or but large standard deviations and large variances, what does that imply? That implies that the data values are far far, far away, far from the mean. And if they're like farther away from the mean, farther away from the mean, that what does that mean? That means they're more variable. That means they're more dispersed. So when they ask a question like, find the standard deviation for these two data sets. You have two S of X's on your calculator. Which set is more variable? So the one that would be more variable is the one that would be the data set that's more variable is the data set that has the one that's the larger standard deviation and the larger variance. So you would look at both of those S of X's. You would look at those S of X values and you would see which one is larger, and the one that's larger is more variant. So you would be looking for these values among both of them. And the one that's bigger would be more variation, okay, more variable. And the quick way to do it is to type that in and use this one variable stats and get that value out of that. But also the long way to do it, or if you want to do it twice, would be to use this formula, and you should get the same thing, the same, when you use this formula, um, oh, I take that back. I take that back. So this is finding the variance. Yeah, this is finding the variance. So I'm just talking about if you're finding the standard deviation, right? Is that what they were talking about here? Sorry. Yeah, just they didn't say find the variance and find the standard deviation. This one just said find the standard deviation. Okay. But you can still look at data sets, standard deviation and their variances. And if you just have to compare the same thing from two data sets, compare two variances. From two data sets, compare two variances, or two standard deviations, and then you would want the bigger one among those two. Okay, and so yeah, so that's S of X to look at those S of X's. Okay, or you can look at the variances, and if you look at the variances to get the variance, you have two ways to get the variance. You use this computational model, which is old school, takes longer. The quick way to get the variance is to take your S of X from the calculator and square it. X squared. That's the fastest way to do it. Okay. All right. Okay. I'm going to stop the recording now. But then when I pick back up, I will show you how to find the, again, uh, one more time, sample variance and sample standard deviation, but for group frequency distributions. So we'll show you that again, but for group frequency distributions. Okay, so we'll take a little break.